Hi, I'm Ashley and I will be attempting to teach you how to do number 72. So first you want to write out your tables of x and y's because you always want to separate your x and your y's. Because as we learned about vectors, is there a component of the x and the y, and then there's the separate x and y components. So you're going to have your initial velocity, your final velocity, your change in displacement, your time, and your acceleration. And you also want to draw out your diagram. For this problem, you're going to have to draw a couple different types of diagrams. So I hope you looked and read at number 72 to see all the givens you are given. So I want to start out by finding the velocity of the dart when it's shot on its own, because there's the dart that it's shot on its own, but then there's also this boy moving as he's shooting the dart. So we'll get to what you have to do at that point a little bit later. So you are above 1 meter and the dart goes horizontally for 5 meters. So you know your initial velocity is 0, so you can cross out that part because it's 0. And you have half acceleration times time squared. And you know your displacement is 1 meter, so you put your 1 meter for your y displacement, and you have half 9.8 gravity and times time squared, and you get time is 0.45 seconds. So now you went 4 meters horizontally in 0.45 seconds, because as we all know that time is the same for both vertical and horizontal displacement. And velocity equals displacement over time, so that's 5 meters divided by 0.5 seconds, which gets you the velocity, the initial velocity of the dart fired on its own is 11.07 meters per second. Now we have to find the velocity of the boy as he moves, which is, he is sliding down at 2 meters per second, so that is our 2 meters per second sliding down at a 45-degree angle, and this is a 90 degree triangle. So as we find the velocity, which is cosine 45 equals velocity x divided by 2, you get velocity equals 1.41 meters divided by seconds. So that is both the vertical and the horizontal velocity. And so now you want to find the total velocity of the kid and the gun. So that's the velocity of the kid and the velocity of the gun equals the total velocity, which is 1.41, which we found here, and that was rounding error. I'll fix that. It's very hard. There we go. 11.07, which we found here. So the total velocity of the dart and the kid is 12.52 meters per second. So before we begin, I just want to clarify that I put 12.52 earlier because I was recalculating some stuff as I was going, and I had some rounding issues, but it's actually 12.48. This is 11.07. So we're going to draw our third and final diagram. So we know that the kid's vertical velocity is 1.41, so obviously it's going to be 1.41. And we know that the velocity of the gun and the boy is 12.48. But we know by physics that it's not going to continually go straight because we have gravity. So the ball is going to go, and then it's going to curve, and then it's going to hit the ground. So what we need to do is we need to use this formula to find the time it takes to hit the ground. And we know that the change in y is 1 meter, as we've had from the beginning. We know the velocity vertically is 1.41 times time, and we know that acceleration is 9.8, and times 0.5 is 4.9. I'm just so used to writing 4.9 because it's always going to be 4.9. So we're going to move the -1 to the right side, and you're going to have a quadratic, so you're going to have to plug that in to -b plus or minus the square root of b squared minus 4 times a times c over 2 times a. And you finally get 0.33 seconds. And we know that the displacement will be velocity times time, because velocity is displacement divided by time. So if you just kind of shifted that around, you'd get that formula. And we know that the velocity is 12.48, and we know that the time it takes is 0.33. So we know that the displacement, or the time it takes, or the total distance, how far the dart will travel, will be 4.12 meters. So I really hope this helped. I tried my best. Good luck.